The velocity v of an object is given after t seconds is this one. V is equal to 4t minus t square. We need to find the greatest velocity and the distance it has traveled when it reaches that velocity. So v is 4t minus t square. When the velocity is greatest or maximum, dv over dt will be 0. So we differentiate this one, dv over dt. Whatever we get, we equate that to 0 to get the time when it becomes maximum. So that is t is 2. Now we can double check whether that's the greatest or the lowest. So what we can do, we can find the second derivative and look at the sign of that. So that will be negative 4t minus 2t. When this one is differentiated again, it's negative, so that's actually maximum. So at t is equal to 2, the velocity is greatest. We don't need to find the greatest value of velocity, but we need to find the distance it has traveled when it reaches that velocity. So we can just integrate velocity from t to 0 to 2 to find the distance traveled. Let's call that s1. So that will be 40 minus t square. So we can integrate that to find the distance traveled. So that will become 4t square over 2 minus t cube over 3 and 2 0 here. So that will be basically 2t square t square minus t cube over 3 and 2 0. So 2 square minus 2 cube 3, and then this part will become 0 anyway, so that's 4 8 minus 8 3, so that's 16 over 3 meters. The unit is not given, so we can say meter or feet, whatever. Then we need to see the time taken for it to return to its starting point. So first we can, so what we can appreciate here is the object goes in one direction, the velocity reaches maximum, then so the acceleration was a positive up to that. After that it starts to decelerate. At one point it starts returning to in the original direction. So and finally it reaches the original point. So let's say somewhere here the velocity is maximum, then it starts decelerating, and at some point the velocity before returning, when it starts to return, the velocity becomes 0. So we can find that point at the time when the velocity becomes 0. We can calculate how much it travels up to that, and we can just multiply it by 2, because after that it will travel the same distance to return to its starting point. So basically we want to find when the velocity becomes 0 to know up to when it's going in one direction, and after that it changes direction. When the velocity becomes 0, it instantly starts moving in the other direction. It's returning, it starts returning. So velocity is given, v is equal to 4t minus t square. We equate to 0 when v is 0. So that's t. So one is solution is t is equal to 0, another one is 4. So initially the velocity is 0. It starts from from 0 velocity, and then after 4 seconds the velocity again becomes 0, and after 4 seconds it starts returning to its original position. So what we can do, we have found s is equal to s1, which is up to 2 seconds how much it has traveled. So we can find s2, which is what it travels from 2 to 4. So that's 4t minus t square dt. Did I write dt before? I don't remember. Yeah, I did. So yeah, just the integration thing. So this one now becomes again 2t square minus t cube over 3 like before, and this is 4 3. So that's 2 4 square minus 4 cube 3 minus then again just the previous one. So 2, so that's 4 2, sorry. So 2 square minus 2 cube 3. So this one we know is 16 over 3. We did that before. and this one becomes 1632 minus 4 times 4, 1664 over 3. So that becomes 96 minus 64, so 32 over 3 minus 16 over 3. So that's basically 316 meter or feet, whatever. So that's the total in one direction it goes, the total path in one direction it goes. We can sum these two up, or we could have actually integrated this integration from just 0 to 4. If we did that, we would readily get the total path traveled in one direction. So that would be 16 over 3 plus 16 over 3, which is 32 over 3. That's the distance traveled in one direction, and when it comes back, it will be multiplied by 2, so that should be 64 over 3 meter or feet, whatever. So that is the amount of distance it travels when it comes back. So basically this whole path, this one, and then the return path. And if we integrate the velocity, and we get 2t square minus, so that's what, minus t cube over 3 plus c, just the integration, and at t is equal to 0, the distance is also traveled 0, so c becomes 0, the integration constant, if we look at this one. And then if we want to solve when the displacement is 0 again, if we want to do that, so we can find the time here by just equating it to 0. So basically when the displacement is 0, we are trying to find that. Just we are trying to figure out what's the time. We haven't been asked that, but we are just trying to do that. So t here, that would be 2t minus t, actually, 2 minus t square over 3 is equal to 0. This one was 2t square, so if I take t square out, it would be 2 minus t over 3. So t square and 2 minus t over 3, I'm rewriting it. So like that. So one solution is t is equal to 0. That is, initially the displacement is 0. That we know. The other one is where we are trying to find out when it returns back to the time we are trying to find out. So 2 minus t over 3. So that gives t is equal to 6. So after 6 seconds it comes back. So that means when it goes in the forward direction, at time is equal to 2, it reaches maximum velocity, then it decelerates, then it, after 6 seconds, it starts to, so these are all t, after 6 seconds it starts to come, sorry, at 2 seconds it reaches maximum velocity, after 4 seconds it returns, and then this time it travels faster, that doesn't matter. So within 2 seconds, that means after 6 seconds it again reaches its original starting point. So that doesn't matter. That means that this velocity was faster. We were not looking at that. So we were just looking what is the distance traveled, which is just this displacement, this amount of path traveled multiplied by 2. But we have just figured out how long it took for the particle to come back to its original position.